Hello and welcome to the section 6.3 lecture. Today we're going to be talking about comparing functions. We want to be able to compare the functions that we see based on tables, graphs, and equations, and have the ability to see like maybe which one's bigger at what point and some of that other information. So the first section here says comparing a table and an equation. To compare a function when written as an equation and another function represented by a table, we would want to find the equation for the function in the table because equations we'll find are easier to compare than scattered points on a table. Right, it says Josh and Maggie buy MP3 files from different music services, and the monthly cost Y dollars is, for X songs is linear. The cost of Josh's service is Y equals 0.50x plus 10, and the cost of Maggie's service is shown in the table right here. So basically, we want to figure out who has the better deal for different numbers of songs. Okay. So they want us to start off by finding the equation of the table. And so for that, we can follow some steps that we've done. We can treat them as given 2 points and find the slope and y-intercept. So that's what they do. They pick the first 2 points. I guess a pen would be helpful. All right. So they're picking the first 2 points here. And they're finding the equation. Sorry, we're having some pen issues already. That's good. So they pick those first 2 points. They find the slope, y2 minus y1 over x2 minus x1. And they find out that the slope is 0.99. And then they want to find the y-intercept. Okay, so they pick a point. They choose the first point that is given in the table, which is a valid selection. They put the 4.95 in for y and the 5 in for x. And they find out that, gosh, is that right? Yeah, I guess that is right. 0.99 times 5 is 495. And so when they subtract that from both sides, they get that the y-intercept is 0. Okay, so they get the equation y equals 0.99x. And then for that, or using that information, it might be helpful to try to figure out who pays more, or maybe which service costs less. And that's what they're looking for, is which one is cheaper, and specifically when 30 songs are downloaded, right? And it doesn't have to be 30, just this problem deals with 30, so that's why we're looking at that. But you could investigate which one was cheaper at, if you purchased 3 songs or 30 songs or even 100 songs. But it turns out when you plug the numbers into the equation, for Josh's service, you have 0.5 times 30 and then plus 10. 0.5 times 30 is 15, plus 10 is 25. For Maggie's service, it's just 0.99 times 30, which is $29.70. And so we find out that Josh's service is cheaper. Okay. But as I said, you could also figure that out at different values of numbers of songs. Let's try this your turn problem. It says that Quentin is choosing between buying books at the bookstore or buying online versions for his tablet. So whether he wants the physical books or the digital books. So the cost Y dollars of ordering books online for X books is, so the online version is given by the equation y equals 6.95x plus 1.5. So to put that in somewhat of a perspective, it's probably $1.50 for using the online service, and then $6.95 per book, so to speak. So the cost of buying the books at the bookstore is shown on the table, and we want to know which one is cheaper for 6 books. Because I don't have 6 books on this table, I'm going to have to find its equation. So we find the slope. Let's use $15 and $7.50. And that's going to be over 2 minus 1. And it turns out that that is $7.50 over 1. And so my slope is $7.50. So I have y equals, I'm going to write 750 as just 7.5x plus b. And if we plug in even that first number, we should see something good is going to happen. Kind of like what happened in the example. 7.5 times 1 is 7.5, and when I subtract 7.5 from both sides, I get 0 equals b. So this one has an equation of y equals 7.5 times x. Or you could say x plus 0, but that's just a waste of time. So we want to figure out for buying 6 books with each strategy. We want to know which one's cheaper. Okay, so we have y equals. Let's do the bookstore first. If I have 7.5 times 6, that's going to be $45. So this side is the bookstore. And over here, we'll do it for this equation. Say that we have y equals 6.95 times 6 plus 1.5. So we need some values there. It's going to be $41.70. And when I add the 1.5, I get $43.20. And this is for the online version. I'm going to say the Kindle version. So which one is cheaper? Oh, they asked for which one is more expensive. So we would say that the bookstore is more expensive. I apologize for this. That is terrible, terrible, terrible writing. I still haven't figured out why my pen lags. It only lags when I'm recording. Like I said, I wish I knew why. Because I've noticed that in class it doesn't lag as bad. Okay. The next one here is about comparing a table and a graph, which is something that we can do just like we compared a table to an equation. The table and graph show how many words Morgan and Brian typed correctly on a typing test. For both students, the relationship between words typed correctly and time is linear. Okay, so we want to find unit rates basically how many words they're typing per minute. So for Morgan, her value or his value is given on the table. So we have 30 divided by 2, which is the same as 60 divided by 4, 90 divided by 6, blah, blah, blah. To find the unit rate, he or she typed 30 words in 2 minutes. So that's going to be 15 words per minute. For Brian, it's a little bit tougher to tell, but let's use this point right here because I have really good values. They both have. I can figure out that this is probably 3 minutes, and that's 60 words. So 60 words in 3 minutes is the same as 20 words per 1 minute. I just do the division there. Which student types more correct words per minute? That is a Brian. Brian types more correct words in 1 minute. And we could have seen that on the graph as well if I thought of this as, how do I get to 60 using 3 lines? It's probably 20, 40, 60, and 20 is right here on the line at 1 minute. Right, 20 is on the line at 1 minute, and that would have been enough to see that as well. Kind of tough to tell on some given graphs. Katie types 17 correct words per minute. Explain how a graph of Katie's test results would compare to Morgan and Brian's. So the one thing that they didn't have us do, which I think we can, is to actually graph and show the relationship on the graph of Morgan's test. So let's try to look at that. So 15 words in 1 minute, and that one's kind of tough to tell. What I'm going to use the 4 minutes, I think. Yeah, because that's 60 words in 4 minutes. So Morgan's line goes through this point right here and through the origin. Knowing those 2 points is enough. And so Morgan's line would be about there. And this is sort of an estimation. I have a pretty good idea, but I'll bet it's right about there. And just by looking at that graph, you can see that for the entire graph, Brian's going to be typing more words because Brian's line is above Morgan's line. And so this has a unit rate of 15, this has a unit rate of 20, and I would say that somewhere in the middle, let's put it in yellow, somewhere in the middle of those two, yeah, here we go, come on. Somewhere in the middle of those two would be this new person, Katie's results. Okay. So explain how the graph of the test results would compare. I'm going to say that I'm actually going to type it so I don't have to deal with lagging pen while I'm trying to write things that are legible. Katie's results would be between Morgan and Brian's results. Okay. So Katie's results would be somewhere in between them. In other words, Katie's going to type more words in the same amount of time than Morgan, but less words than Brian. Okay. let's compare a graph and a description. So it says Jamal wants to buy a new game system that costs $200. Not many of them cost $200 anymore. He does not have enough money to buy it today, so he compares layaway plans at different stores. The plan at store A is shown on the graph. So what this looks like, just to talk it out, is that that's a weird way to show it. 20, 40, 60, 80, 100. So if you owe $100, you can pay it off, it looks like, in 10 weeks. By basically paying, if I use this point, it looks like paying $20 every 2 weeks. So that's probably $10 a week. That makes sense for $100 paid off in 10 weeks. Now, how that really helps us on the $200, I'm not sure. I don't know if it just escalates or not. We'll have to see. It says here that store B requires an initial payment of $60 and weekly payments of $20 until the balance is paid in full. Write the equation for the slope-intercept form of store A's layaway plan. Let X represent the number of weeks and Y represent the balance owed. Okay. So to do that, we're going to have Y equals. We just want to write this in slope-intercept form, and I basically already talked about it. In that you have to pay $10 a week. So we'll say that's a negative 10 because the balance owed is going down, negative 10x. And in this case, we have plus 100. It starts at 100. We want to write the slope-intercept form of store B's layaway plan. They require an initial payment of $60 and payments of $20 until the balance is paid in full. So again, we're going to let Y represent the balance owed. And if the system costs $200 and he has to initially pay $60, the amount that's going to be owed after paying $60 is going to be $140. So this one's actually going to start at $140, kind of writing this backwards. And you have to pay, so you have to take away from that balance owed $20 every week. Okay. And we want to sketch the graph of store B's on the same grid as store A's. So we're starting here at 140. So we're going to start at 140. And we're going to pay $20 every week. $20 every week, $20 every week. Every line is $20. So this becomes a little bit easier. I'm actually going to connect it with a line. Go a solid line for this one. And I kind of missed that one there, didn't I? Let me adjust that point. Adjust my starting point just a little bit. And so that's what that line would look like. Okay, paying $20 every week with an initial cost of, or an initial balance owed of $140 because we paid $60. How can you use the graphs to tell which plan requires the greater down payment? And how can you use the equations? Okay. So based on the amount that, I guess it really doesn't matter. The 200 in this case is the driving force behind this. The initial cost was $200. So for both of these graphs, they're a little bit odd in the sense that they would really start up here at $200, but right away they're taking jumps down to 140 and 100. So they just have to jump right down right away because that's the down payment that you have to pay. So the way we can tell on the graph, or the way we can tell in our situation, is that we started at $200, and for Store A, it drops down to $100. For store B, it drops down to $140. So which one requires a bigger down payment if they both start at $200? Again, store A goes from $200 down to $100. Store B goes from $200 down to $140. So store A requires a bigger down payment. Sorry, I'm going to type it again. I can't take it anymore. And let me drop that size down a ways. We'll go 18. So store A requires a larger down payment. Because we see that, I'll move this in a second, the Y-intercept is lower on the graph. Okay, and how could we use the equations to tell that? The equation from store A has a lower Y-intercept. So the same sort of way that we could tell that information on the graph showed us that same idea on the equations. How can you use the graphs to determine? Let me just start typing. That's going to be a big size. Let's go back to that 18. How can we use the graphs to tell which plan has a greater weekly payment? So which one has a greater weekly payment? It was store B. They required $20 a week to be paid. Okay? So store B not only goes down 20 and over 1, but it's also just a steeper line. The graph with the steeper line represents a greater weekly payment. Which plan allows Jamal to pay off the game system faster? Well, which one pays it off faster? And they say, I think they said, lets him pay it off faster. It's more like makes him pay it off faster. And I would say that store B requires Jamal to pay the system off faster. The way we can tell that on the graph is that the amount owed, is it amount owed? Is that what they said? Balance owed, same idea. The balance owed hits 0 faster or in less weeks. Okay. And that's how that's kind of our explanation. That's how we know that store B does that. And I believe that is it for today. Okay, I think a good code word for the day. Yeah, we'll go with our own, sort of. Our code word will be comparison. because that's what we did today. We compared our functions. So I hope that helps bring a little bit of light to more things that we can do with functions. And yeah, I hope that made sense. If you have any questions, feel free to let me know. Otherwise, get the reflection done and make sure you get the right code word. And we will see you in class. Have a good day.